Welcome back to the deep dive. So today we're doing something a little different.
Yeah, a bit of a change of pace for us.
A huge change of pace. Usually we're up here looking at these big, macro trends, big tech, global economics, that kind of thing.
The 30,000-foot view.
Exactly. But today we're zooming all the way in. Microscope level. We are looking at industrial fittings.
It sounds incredibly dry, doesn't it? I can just hear some of our listeners reaching for that skip button.
I wouldn't blame them. A valve, a connector. It sounds like the driest topic imaginable. But here's the thing, and this is why I got so fascinated by this. It's the ultimate iceberg topic.
Right.
You see this tiny piece of metal and it looks completely insignificant, but that little piece of metal is often the only thing holding these massive, high-stakes systems together.
It's the classic linchpin scenario. You ignore the small stuff and the really big stuff falls apart.
So the source material we're digging into is called the hidden cost of cheap fittings. And our mission today is pretty straightforward, but I think it could be a bit mind-bending. We want to challenge how you look at a price tag versus the actual cost of something.
And that distinction is just vital. The core question this source asks is the price on the invoice the real cost?
Right.
Because in the industrial world, whether you're running a refinery or a manufacturing plant, those two numbers almost never line up.
We're going to find out why the cheapest decision on some spreadsheet is often the most expensive mistake you can make in the real world.
And it's not just about money, though the financial side is, well, it's real. It's about risk. It's about safety.
Okay, so what's the roadmap?
We're going to uncover why cheap is so tempting, then look at the disastrous hidden costs of failure downtime, safety risks, and then we need to zoom right in on the microscopic engineering details, the stuff that separates a quality part from a liability.
Let's unpack that. We have to start with the trap. The source calls it the paper illusion, and I think this goes way beyond industrial buying. It's a cognitive bias.
It really is. In procurement, the pressure is intense. You've got targets to hit, a budget to meet.
You've got a boss asking why you didn't go with the lower bid.
Exactly. The source really highlights that psychological pressure. And in that environment, the spreadsheet becomes your reality.
You're just looking at rows and columns. Vendor A is offering a fitting for $5. Vendor B has one for $3. If you don't know the engineering, the $3 one looks like an obvious win.
That's the core problem the source gets at, commoditization. The assumption is that a fitting is a fitting is a fitting.
So if the spec says 316 stainless steel, the spreadsheet treats them as identical.
Precisely.
Okay, but here's where I want to push back a little. If they're both rated as the same material, shouldn't they basically be the same? Why is the spreadsheet wrong?
And that is the trap. The spreadsheet captures the category, not the composition or the craftsmanship. The source has this great line that says, they look the same on paper, but in real-world applications, they couldn't be further apart.
Because the spreadsheet doesn't have to hold back 5,000 psi of pressure.
That's it. The spreadsheet doesn't vibrate. The spreadsheet doesn't corrode in salt air or deal with thermal cycles. There's this huge disconnect between the neat financial world of procurement and the chaotic physical reality of a plant floor.
Okay, so let's talk about what happens when that reality hits. The source breaks this down into the hidden costs. And honestly, this section was a real wake-up call for me. It lists 4 main pillars.
And the first one is the big one, downtime.
This feels obvious, but the scale the source describes is just staggering.
Well, think about the leverage involved. The source talks about a scenario where a single failed fitting a part that cost maybe $5, $10 shuts down an entire production line.
You save $3 on a part, and the whole factory grinds to a halt.
And when that line stops, the cash register stops, but the expenses don't. You're still paying salaries, overhead, utilities. The source emphasizes that the lost production costs just dwarfs any initial savings. It could be tens of thousands of dollars an hour.
That is the definition of tripping over dollars to pick up pennies. But surely most systems have redundancies built in, or is that just wishful thinking?
In some critical systems, yes, but a fitting is often a choke point. You can have 2 backup pumps, but if the connector to the pump shears off, you're dead in the water.
Okay, so that's downtime. The second pillar is rework and replacement. And when I first read that, I thought, okay, so it breaks, you swap it out. What's the big deal?
If only it were that simple. The source paints a much, much grimmer picture. Rework isn't just unscrewing one part and screwing in another.
Right, because if a cheap fitting fails, it doesn't fail cleanly, it fails destructively.
Precisely.